Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 21. Today we will be talking about the centroid. First, we'll review points of concurrency, then we'll look at if medians are concurrent, and lastly, we'll try to balance a triangle. So our points of concurrency. Let's review what happens when we have the three angle bisectors. Are they concurrent? Where do they meet? What about the perpendicular bisectors or the altitudes? Try to review in your head as I show us the picture. The angle bisectors meet at the incenter. The perpendicular bisectors will meet at the circumcenter. And the three altitudes will meet at the orthocenter. Today we'll look at medians. Are they concurrent? So first, we're going to draw a large scalene triangle and label it CNR. We're going to locate the midpoints of the three sides and construct the medians. Remember that the medians are the midpoint of the side to the vertex across from it. So when I did this, here is my triangle. You can see that the three medians are concurrent. So the three medians of a triangle are concurrent. The point of concurrency of the three medians is called the centroid. The centroid is the point of concurrency for the three medians. Now let's continue this investigation. Keep your triangle handy. We're going to label the three medians, CT, NO, and RE, and we're going to label that centroid in the center, D. We're going to use our compass, or maybe another sheet of paper, to investigate whether there's anything special about the centroid. Is it equidistant from the vertices? Is it equidistant from the three sides? Is the centroid the midpoint of each median? If none of those work, let's try something a little different. The centroid divides the median into two segments. We see a longer segment and a shorter segment. Let's use our patty paper or compass or maybe even a ruler to compare the length of the longer segment to the length of the shorter segment and find a ratio. Is the ratio of the length of segment parts the same for the other two medians? Here's a video of how I looked at that. Here's my triangle. I'm going to use my compass and I'm going to compare distances here. From the centroid to the vertices, oh, not the same. Okay, how about from the centroid to the sides of the triangle? Not quite the same. Oh, and that one definitely isn't. So how can I compare the lengths of the medians, the two different segments? I decided to get out my ruler. I'm measuring in centimeters, and I am estimating a little bit. I did not get down to the nitty-gritty decimals, but I went close. So my first short segment, I said, was about 2.5 centimeters. And then the longer of that median was 5 centimeters. On my second one, the longer segment seems to be about 3, and the shorter one about 1.5. 3 for the short one on this one, and 6 for the longer one. So if I'm looking at the ratios there, from the short part to the long part, I'm getting double. The short one is half of the long one, or the long one is double of the short part. So do we have a conjecture here? Our centroid conjecture is the centroid of a triangle divides each median into two parts, so that the distance from the centroid to the vertex is twice as long as the distance from the centroid to the midpoint of the opposite side. So from the centroid to the midpoint is always the shorter segment. To the vertex is the longer one. And that longer segment from the centroid to the vertex is twice as long as the distance from the centroid to the midpoint. Now, in earlier lessons, we discovered that the midpoint of a segment is the balance point or the center of gravity. We also saw that when a set of segments is arranged into a triangle, a line through the midpoints of the segment can act as a line of balance. Let's take a look at that in our next investigation. Does a triangle balance the same way? Can we balance a triangle along its median? We're going to use the same triangle that you just drew all your medians on and found your centroid, and we're going to trace it onto a piece of cardboard or cardstock. I used a sharp pencil tip to mark the 3 vertices and the 3 midpoints, and then the centroid of the triangle. I didn't even have to mark the centroid because I was drawing my medians. So once I had those points marked, I drew my triangle and medians onto the cardboard. I then cut out the triangle very close to the edges as possible. So being very accurate in your cutting. Then you're going to try balancing the triangle on each of the 3 medians. I use the edge of a ruler. In fact, I use that metal part of my wooden ruler. You can use anything that is going to be a very thin line, and try balancing your triangle. If you're successful, what does that imply about the areas of the 2 triangles formed by one median? What do you think? I wonder if those areas are the same if it balances. Is there a single point where you can balance the triangle? Our book tells us to use the pencil tip to try to find a balance point, but I found that was a little difficult, and I used the eraser end of my pencil, but I was able to balance the triangle on just the eraser end of my pencil. So let's take a look. Here is the first median, and I got it to balance on the edge of the ruler. It did take a little bit of practice. That's why I didn't have it on video this time. Here is the second median of my triangle, and I was able to balance it on the edge of the ruler. And here's my third median, balanced on the edge of the ruler. And then it took a little bit of time, but you can see that when I balanced it on the eraser end of a pencil, it was right there at the centroid. So the center of gravity, if you found the balancing point for the triangle, you have found its center of gravity. The center of gravity is the center of mass, which would be the point that an object could balance. So a conjecture here. The center of a triangle, the centroid of a triangle, is the center of gravity of the triangular region. So that point that we found, the centroid, that is the center of gravity of our triangle. The triangle balances on each median, and the centroid is on each median, so the triangle balances on the centroid. As long as the weight of the cardboard is distributed evenly throughout your triangle, you don't have cardboard that's lumpy on one side, then you can balance any triangle at its centroid. Think about some ways that this might be helpful. The centroid is a very useful point of concurrency, especially in physics. Maybe in building something. Can you think of some ways that it would be helpful to know the center of gravity of a triangle? The idea is useful in designing structures as complicated as bridges or simple as furniture. Knowing the center of gravity is very helpful as you design and build things. So a quick review at the end of this chapter. We have been talking about points of concurrency and end centers and centroids. The end center is the center of an inscribed circle. So you can see our triangle here, and our incenter. The incenter is going to be the center of this circle, and this circle is inscribed inside the triangle. Our circumcenter is going to be over here for the triangle, and the circumcenter is the center of a circumscribed circle. So the circle that goes all the way around the triangle and touches the vertices, the center of that circle is at the circumcenter. And then the centroid of our triangle is going to be the center of gravity for the triangle. I think the center of gravity for those circles are going to be the center of the circles. Remember that this is the end of chapter 3, and you should make sure that you have reviewed and tested your knowledge before you move on to chapter 4.